Well, it's not quite 1:30, but I'm so excited. We're going to go ahead and get started. First of all, I want to say hello and welcome to SAS Innovate. If you haven't been to any of the pre-conference things yet, let me be the first to welcome you. And I am thrilled that you are here at our SAS Users Day activity event. My name is Shelley Sessoms. I am the liaison between SAS and the US-based user groups. My colleague is here, Franz, and he works with the FANS group in the Nordics. We have user groups in Canada, we have user groups in France, we have user groups in the UK and Ireland. We have over probably 17 user groups in the US. And so let me tell you a little bit about what you're going to find out today. This is today's agenda. We have 5 speakers from our user groups. 4 of them are in the US, and then we have 1 from Poland, and he is also presenting during the conference, so you'll hear from Bart in a little bit. But in the US, user groups are volunteer run. So it is a group of people getting together with so much love for SAS that they want to use their free time, if any of us have any free time, to pull together meetings. It can be a 1-hour webinar. It can be half-day, full-day, multi-day, in-person events. And many, many, many hours are spent planning these events. And so some of the speakers you're hearing from today have presented at these events. They have helped lead these events. We'll tell you a little bit about them later on, close to closing session, because many of them have events coming up. So that's what we're here for. So I see a lot of familiar faces and a lot of new faces. Who used to go to SAS Global Forum? All right. So what you're going to see today is a lot of what you would have seen at SAS Global Forum. It is user-generated content. It is content that is in practice. It is content that people have created to share what they're doing to help others who are in the same situation. Now, we all know SAS Innovate is a wonderful conference, and you're going to learn a lot of new things, a lot of upcoming things. You're going to see some presentations about some of the software that you are using now, but these presentations are for you, the user, because they're created by SAS users. So I've been running through some of the slides. I will ask you at the end of each presentation or at the end of this event, please give us a rating. Please go into the app and tell us what you thought of this event. This is the first year we've done this, and so we want it to be successful because we want to keep doing it every year after this. So we'll get started. I'm going to introduce our first speaker. Our first speaker is Michael Saleh. He is an Associate Dean and Associate Professor of Business Analytics at Stonehill College's Meehan School of Business, where he leads a range of academic and professional initiatives, and he's been on the faculty for nearly 20 years. So come on up, Michael, and we will get your presentation all set. There you go. Oh, nope, that's mine. That's yours.
It's not showing though.
It should switch. There we go.
Hi, everybody. Thank you so much. Hopefully the slide stays on. As Shelley said, thank you, Shelley. My name is Mike Saleh. I'm an Associate Dean at Stonehill College. I'm also on the steering committee at the Boston area SAS users group. So we do monthly webinars and 1 or 2 in-person events as well. So I come to, my main role, at Boston area SAS users group is as the academic ambassador. So I kind of try to bridge the gap between the professional world and the academic world. And so what I'm teaching my students in the classroom versus kind of what industry is asking for, and also kind of sharing best practices between the two. So my presentation today is maybe a little bit like how I approach SAS with some of my students, but also has helped me and throughout my professional work with SAS as well. There's me. So kind of one of the interesting things that I talk about with my students, I teach a couple SAS programming courses on campus, a basics course and kind of a more graduate level SAS course as well. And when I talk to my students about SAS, obviously SAS is a data engine, it's a programming language, but I also think of it as a way to use repeatable patterns to reuse over and over and over again. So when I'm writing code, and I'm sure a lot of us in the room, when we're writing code, when we write code, it's not like we're doing it all for the first time every single time. We have repeatable patterns that we say, I need to solve this problem, and when I need to solve this problem, I use this method. And I think if I put out a problem out there and ask people in the room to solve it with SAS, I would imagine we'd come up with lots of different solutions, right? Are you going to use ProcSQL? Are you going to use a data step? Are you going to do this? Are you going to do that? So what I've done over the years, and what I tell a lot of my students, and I've done professionally, is find a way you like to solve a problem when it comes up that's been efficient for you, that works really well. Maybe you refine that code over time, and then save that code somewhere. Save it as a snippet, save it as in a WordPad file. I don't care how you save it. But save it so that when you come across that problem again, you have that party trick to pull out of the bag. And that you can say, yeah, I'm going to use this pattern, this coding pattern, to solve this problem. So what I'm going over today is kind of what are my party tricks that just a few of mine. And none of it, I'm assuming, will be earth-shattering to a lot of people, but I do use some of the procedures and some of the methods in SAS in somewhat unconventional ways every once in a while. Ooh, didn't realize that was going to look like that on the screen. But so I'm going to look at 6 patterns today. And the 6 patterns hopefully will help reduce repetition, especially, and build some more scalable workflows. And so what I'm trying to do is show you what is the problem or what is the thing we're trying to accomplish, the code I use, and then what that result is and how you might be able to tweak that code. I'm using really simple data sets today. I'm not doing anything involved with 10 million row data sets. We're literally using sashelp.cars for many of my examples today. If you don't teach with sashelp.cars, something's wrong with you. So these are the patterns. My students are so tired of learning about cars from 25 years ago, but that's okay. I don't care. So today's patterns that I'm going to talk about are first dot and last dot, retain, formats, it's kind of a different way of using formats, arrays, hash objects, and ODS output. So these are kind of my six party tricks that I have code set up for that I reuse over and over again for solving different problems. And some of them we maybe learned when we started learning SAS and then forgot about them. Very often I'll be talking to someone and I said, well, why don't you just do that with first dot and last dot? And they completely forgot that that was an option. And so, maybe I'm like Kellogg's Corn Flakes today. You're going to taste it again for the first time, okay? That was the slogan. Okay, it's fine. All right, so problem number 1, pattern number 1, first dot and last dot. So the problem is, again, we're using sashelp.cars. If you're not familiar with it, you can Google it and I'm sure find the data spec for it. But for each car make, so sashelp.cars has makes, models, MSRPs, horsepowers, all kinds of stuff in it. I think there's about 15 columns in that data set. So for each car make, I want to identify the most expensive model. So something we do often. Now, can you do this with a whole bunch of if statements? You sure can, but life is very short, so I'm not sure you'd want to do that. So that's what we want to do. So first dot and last dot are automatically invoked or created when you use a by statement. So here at the bottom, we require a sorted data set, so I'm going to use, in my code you'll see in a moment, I'm going to use the by make option or the by make command. And when you do that, SAS automatically creates a first dot variable and a last dot variable automatically. And those are in your program data vector, in your PDV. And so these indicate whether it's the first row in a group or the last row in a group. And you can nest these. So you can do these in subgroups even. You can process multiple first dots and last dots depending on how you nestle these inside your code. I'm keeping it simple today just for proof of concept, just to kind of show you it in work. So here's my very simple code. We are just sorting the data set, sashelp.cars, and I'm assorting it by make and then the MSRP, because I want to find the most expensive car, and so in order to do that, I have to sort it by MSRP, and I'm sorting it descending because that's going to hit the most expensive one by make first. So think about what this data set looks like right now. It's going to have all of the same makes together, and the first one of each make is going to be the most expensive one because I'm sorting it descending by MSRP. Then we have, I'm just using a data step to take that sorted data set, and I'm saying by make, there's by make, if first dot make, okay? So I'm only outputting this if it's the first one of each make. So I'm only including it in the data set if it's the first one for each make, which means it's always going to be the most expensive one because it's sorting it first by make and then descending MSRP. And then I'm just printing them out. I'm only printing out 10 observations. So this is what that's going to look like. So you'll see that I do have by make the most expensive model and type in origin. And that's all processed because of the way I sorted and the way I use my first dot. Now you can use first dot and last dot with a lot of other commands or options in SAS. In fact, one of the next ones I'm going to show you, such as retain or the sum statement, you can use these to do things like keep running tallies of things, keep sub-tallies of groups. For example, one of the labs that I give my student is they have to pretend they're running a conference like this. They have to pretend they're running a conference. And when a user registers for the conference, they get all kinds of line items on their bill. How much does it cost for the conference? How much does it cost for the add-on session they bought, their room, their meal plan, all these different types of things. And I said, I want you to be able to make me an invoice for every single person who attends our conference. And so they rely heavily on first dot, last dot, and the sum statement. So they can go by user or by attendee and add these things up together. So once you learn the fact that SAS automatically knows when you're in a first record of a group or you're in the last record of a group, you can do a lot of additional processing based on that. And it's great because it's automatically there and it's automatically in your PDV. I love showing to my students when I'm using first dot and last dot, we hop into Enterprise Guide and I show them the first dot and last dot variables just kind of sitting out there and changing as SAS loops through the data set. So it's kind of neat. Okay, speak of the devil, as we were just talking about a minute ago, the second pattern is retain. So we all know, and I think one of the hardest things that I know when I'm teaching either a student or someone who's new to SAS, kind of how SAS works, especially in a data step, is that SAS is in a loop. That's how SAS processes data. In a loop, when we're using a data step, it's just looking at every row one at a time, but when we go from one row to the next, we lose what was in the previous row. The PDV, which it's funny, I use the SAS curriculum when I teach my classes, and the SAS curriculum introduces the PDV in like week 7, and I made that now week 2, because I feel once you understand that, my gosh, things are so much more clear to see what's going on in SAS's brain in the back, and that's really, really neat to see what the engine's doing. So My problem here, same data set, we are going to use one other data set, so don't get too used to sasshelp.cars. You want a running total of invoice by make. So we're still grouping by make, but we want to do what I just talked about a minute ago. We want to be able to get a subtotal by make. So for every single make, I want a total of all the MSRPs to see, you know, maybe I own all these cars and I want to see how much they're worth. So again, by default, SAS resets variables for each row. So if you try to set a variable like some MSRP, let's say we're going to call it SUM_MSRP. If we try to do that and just try to keep adding it from the current row, it's just going to keep resetting every single time. So that's not very helpful. The retain statement preserves values across the row. So I like to think of it as it's a state. It saves the state across observations. And this is incredibly helpful when we're trying to do something in a loop, but SAS is getting in the way and resetting. Sometimes that's great, but sometimes we obviously don't want that. So here's how I solve that problem. Again, I'm sorting it by make and model in this particular case. And here I'm doing setting my cars by make. That's my sorted data set. And I'm saying retain total invoice 0. So what that line is doing is it's creating a variable that it's going to retain for when I start looping through the data, and it's setting its initial value to 0, okay? So if it's first.make, you'll see now I'm using my logic from my first pattern here in my second pattern. So what I'm doing is because I invoked by, I now have my first dot and last dot available to me. And so I'm saying if first.make, then total invoice is 0. So in other words, if we're on the first car of the make, reset the total to 0, because we're going to start accruing from here on. Otherwise, total invoice plus invoice. So that's our sum statement, okay? So that's a sum statement. So what that's doing is that's really the same thing as saying total invoice is equal to total invoice plus invoice. It's just a shorthand way of saying it, okay? And then I'm printing all that out. I was going to show you this in SAS Studio, but trust me, the results on the next screen are exactly what would pop up in SAS Studio. I don't have to do that. So this is what we've got. Now I will say there is one line of code in here I did forget to put in. I'm going to not lie to you. I did add a format to the total invoice column. So by default, that format was just numeric. So I did add I think it was a $10 dot format. So you'll see what it does is when it gets to the top, it will reset by make and model, and it will, for each make and model, it is going to add up those MSRPs. Okay. So this is really, really helpful. I use the retain statement a lot when I'm creating reports. When I'm helping students learn how to create reports where we have to sum by group or get group averages or things like that, the retain statement is very, very helpful. Because I feel that students especially, and even professionals that are maybe learning Python first or R first or other languages that kind of don't run in the same kind of logic as SAS as a loop, you know, where it prepares data sets, this is a really easy way to say, hey, here's how you kind of can use kind of some of the thoughts you have from the Python and R language in here. And they don't feel like, oh gosh, so how do every single time I go to the next row, everything I just did in the last row is missing. Okay. This one's my second favorite that I'm going to show you today. So this one is using formats. So we all, I would assume, have played with formats. I have a whole separate workshop that I do on formats alone, creating custom formats, creating formats that you can save to your libraries. But this is a simple but interesting way of using formats. So what I want to do here is I want to group cars into miles per gallon performance bands. So the sasshelp.cars dataset has a column that indicates what their miles per gallon city and miles per gallon highway that they get when they're on the road. And what I want to do is take those and put them into performance bands. So is this a high MPG car, medium MPG car, or, you know, is this a gas guzzler? So how could I do that? Well, obviously the first way that if I were a new programmer that I would do that would be with if statements, right? We'd create a new column that's called performance band, and I'd say in my data step, if the MPG is between this value and this value, they're this performance band. If it's between this value and this value, it's this performance band. Okay. The other way we could do it is we could use a format on that column and replace it, have the format kind of show instead of the MPG, right? So I could create a format on the MPG column that instead of showing the MPG, it shows the performance band, and that works too. But what if we want the best of both worlds? What if we want a column that shows the band and we also want to be able to but keep the original column without doing if statements? So what I'm going to do is I'm going to use using formats to map the values to category, but I'm not going to replace the column. I'm not going to actually format the MPG column. I'm going to create the format and store the value of that format in another column. So now we've got a format and a column with that value of the format, and you're going to see how I'm going to do that. So I've created, excuse me, just getting over a cold. So I created a format here, and you'll notice here they are, very simple, and I'm calling it MPG-FMT, from low, which takes the lowest format possible, to 20, less than 20, it's low MPG. From 20 to less than 30, it's moderate MPG. And from 30 to high, which takes the highest value, no matter what, it's dynamic, I have a high MPG. And now notice what I'm doing in my data step. In my data step, notice I'm not applying the format to the column, okay? I'm not applying the format to the column. What I'm doing, so the column is MPG city. That's the column I'm actually looking at to decide which format band or which MPG band that it's in. What I'm doing is I'm creating a new column called MPG band, and I'm putting the value that the format is deriving for MPG city in that column. So it's actually putting the data there. It's not a dynamic format that's just showing on a report. It's actually putting the value there. So I notice there's no if statements here. There are no if-then statements in here. And then what I'm doing, notice below, is that I'm running a simple procfreak on the actual MPG band. Now, of course, you could do this as well on the formatted column, either way. But this is just showing a way where I keep my original column, so I haven't altered MPG city at all. It's still MPG city. It's still going to come out in my report, into my proc print, if I were to do that. But I'm using the format value now to make procfreak. So here's my procfreak statement. And so now I'm getting my MPG for high MPG cars, low MPG cars, and moderate MPG cars. Now, if you're like me, you probably knew about 4 different ways to do this, right? That's the beauty, I think, of SAS, actually, is that there are a lot of ways. I was reading somewhere. There are a lot of ways to feed a cat. I was reading that somewhere. Don't say a lot of ways to skin a cat. A lot of ways to feed a cat. So, you know, you could have certainly, like I said, formatted that column and done a procfreak by the formatted column. But this is one way to have your cake and eat it too. You can keep the formatted value, or keep a format column, or a character column rather, sorry, and your original column. So it's using formats in a little bit of a different way. We don't usually put formats. It's just a kind of a new kind of a thought. All right, I promised you we would do one that wasn't sashelp.cars. So this is the sashelp.heart. It's one of my favorite data sets to practice on because it has a lot of really great information. By the way, if you don't know where the sashelp.heart data set came from, it comes from my home state. It is the Framingham Heart Study, which was a study done in Framingham, Massachusetts. So I'm from Boston. And so it's a nice data set. I tell my students, oh, this is from Framingham, and they don't care. So, so what I want to do here, and what I'm using an array, I'm using an array in this case, and this we teach in our upper level SAS course. We don't teach arrays in our introductory course. But what I'm trying to do is I want to apply the same kind of logic across multiple variables. And when I started programming in SAS in 1990 something. When I started programming in SAS many, many years ago, I did a lot of if-thens, right? Do it to this variable, and then do it to this variable, and then do it to this variable. And when I discovered arrays, I was like, oh gosh, what am I been wasting my time on? What a great way to apply the same type of logic to a lot of different problems. So here's my 30-second lesson on arrays. So here we can create an array name, and we can add as many variables as we want to that array, and you'll see how I do that. And then I can very easily loop through that array dynamically. And then I can apply any logic that I want to each part of that, or each element of that array without doing any if-then or multiple lines of the exact same code just for different variables. So here's how I'm doing that here. It's just one data step, very simple. So if you don't know the Framingham Heart Study, what it is for a bunch of participants, we hold or we store cholesterol statuses, smoking statuses. It was a cardiovascular study, so it's a medical study. So here what I'm doing is I have one array that I'm calling labs. So in other words, if you were a patient going to participating in the study, they did multiple labs on you, so you would get your cholesterol, your systolic and diastolic blood pressure, and so on and so forth. So I have 4 labs that they had done to them. So that first array labs goes ahead and stores those. Then I created a second array so the purpose, by the way, of this code is that I want to try to find where the data is missing. And I want to create missing flags. And we do this actually quite a lot when we teach data mining, that we talk about the fact that a variable is missing is just as important as the fact that the variable itself. So we often create missingness indicators. So we say this value is missing in this row, because that might be an important piece when we do data mining to say it wasn't the actual missing variable, it was the fact that it was missing is significant. So that's what I'm doing here. I'm preparing this data set, and not only do I want in the data set cholesterol, systolic, diastolic, and MRW, but I want to know for each of those, is that value missing? I want a binary indicator if that value is missing. So that's what this code is doing. And so I'm saying do 1 from I to dim labs. Dim gets you the length of that array. And if missing labs I, and I is dynamically looking at each element, then flags I equals 1. So if the lab is missing, set that corresponding value to missing as well in the missing array. So what it's doing is this is a big, crazy loop that normally this would be 1, 2, 3, 4 if statements that are running in a loop, and it would be kind of, not messy, but a lot of extra code. And here I'm doing it in just a couple of lines. And then at the end, I am just printing both of these arrays, okay? So that's what this is looking like. So notice my first 4 columns are the data itself, cholesterol, systolic, diastolic, and MRW. I forget what MRW is, apologize. And then on the right, I've got the 4 missingness indicators. So if it's missing, it's a 1. So you'll see, notice in the very first observation, cholesterol is missing. We know it is because there's a dot. And notice the corresponding missing CHOL or missing cholesterol is also 1. So this is very helpful. If you, in our case, for example, again, if I'm prepping this data for data mining, that I now have missingness indicators for every single row. And you could do this you could even expand this if you have a lot of variables. Let's say you have 100 variables. There are very easy ways in SAS to have the array hold all those variables without even having to type every single name of the variable as well. So there's lots of different shortcuts to learn how to do that. Just watching my time. Okay, I'm good. Okay, hash objects. So my 4th problem, or my 4th opportunity, back to sashelp.cars, I'm sorry, is my hash object. So here what I want to do is a little bit different. I want to add the average MSRP by origin to every single row. Origin, by the way, in sashelp.cars is which part of the world that the car was made in. So USA, Asia, and Europe, I think, are the 3 origins. So what I want to do is I want to get an average MSRP by origin to each row. So this takes a couple different steps, but once you learn how to do this, it's a 2-step process, and it makes it very easy. So I like, again, a hash is an in-memory lookup table. So it's like having a little table sitting out there in the cloud, not really in the cloud, but sitting out there waiting for you to use it to look up values. So as you loop through a data set, you can reference the lookup table that's sitting out there and pull data from it only when you need it, which is really, really neat. When I learned hashes, I wish I learned them back in my graduate school days. That would have made my data preparation so much easier, but I didn't know them. So what we're going to do first is create that lookup data set and then define a key. So you have to refer to hash elements by a key. It's like a key value pair, okay? And then we retrieve the values as we need it. So first thing I'm going to do is I'm going to build the lookup table. And I'm just using ProcSQL to do this. So I'm creating just a temporary table or a table in using ProcSQL to say create table origin lookup, and I'm selecting the origin in the mean MSRP. Okay, so that's what I'm doing. From sashelp.cars, and I'm grouping it by origin because I need to get the mean MSRP by origin. Okay, so now think of that. You now have this little table that's ready to be used. And I'm going to show you the results of both of these in a minute. Then, what I'm doing is in my data step, you'll notice a few things. I'm going to walk you through a little bit of this code. First of all, the PDV needs to know about this lookup table. Okay, the PDV needs to know about this lookup table, and the only way I can do that, and please share with me at the end of my presentation if you know a better way of doing this, is to use this first line in my data step. So I need to bring this origin and average MSRP that I just created into my PDV so I can use it. And the way I do that is using this little statement. I say if 0, then set origin lookup. First of all, that's always going to be false. But as soon as we do that, when you execute that line, the PDV immediately learns about the origin lookup values. So those values I just created are now sitting in my PDV waiting, okay? Then what I do is if _n_, which means is this the first record we're processing, is 1, then I declare the hash object. So I have my origin lookup that it knows about because it's in the PDV, and I've created a little hash for it. And the key is the origin, right? Because I need the MSRP by origin, so origin is my key that I'm using. And the data I need to retrieve from this hash is the average MSRP, and then I finish defining the hash. So remember how I said earlier, key value pairs. If you work in JSON at all, or XML, or any of these other language or data formats, you know that they all work with key value pairs. So that's kind of what we have here in a hash object. We have the key, which is origin, and the value, which is average MSRP. So I've just created a little hash. Then I took set sashelp.cars, that's just bringing in my cars, and I'm saying RC is h.find. So what it's doing is, as it goes from car to car, it's saying, let's look up and see if we can find that particular origin, and if so, slap it into the data set. Okay, so what I just did is I created a little lookup table, and every time I go to a new row of the data set, I'm saying, did we find origin? And if so, pull in the average MSRP. And then I'm just printing it out. So just want to show you what the result of both of these things look like. So on the left-hand side, here's my lookup table that I've created using ProcSQL. It has the origin, and it has the average MSRP. So that is, I should have put a slide, a screenshot of the PDV, and I didn't. I promise it works. But again, those values are accessible because you used this code right here. Those values are now accessible through the PDV. So we have a hash object just sitting out there, and you notice on the right-hand side, For example, the Acura MDX is from Asia, and the average MSRP for Asian cars are 24,741. And then the same thing works for Europe, and if I expanded this data set, the same exact thing would work for USA, the third one. So I use hashes a lot when I do want to do quick lookup. And this is much faster, by the way, to execute than if you're doing a bunch of if-then statements and whatnot. This executes much, much quicker, especially on data sets that are hundreds of thousands of rows long. Haven't tried it in VIA and CAS, but I'm sure it would be even faster. Home stretch. So the last one is, ODS. I could teach a 14-week course on just ODS. But pick your favorite thing about ODS. It's amazing. It does everything you would ever want it to do and more. I've seen some unbelievable presentations on things. So what you're about to see is pretty vanilla. But just an interesting way that I use ODS for. One of the so don't think about ODS as, in this case, as making data just look pretty on the back end. That's not what we're using ODS for at all. But one of the things that the ODS environment can do is it can export data or export results from some analysis that you do to a data set. So instead of just pumping it out on the screen, which sometimes we want, right? Sometimes we actually want to run a procfreak or a procmeans or a procunivariate or something like that and have those display out on the screen. That's fine. 8 times out of 10, that's what I want. But 2 times out of 10, I want to use the results of that analysis, which would normally pop up on the screen, in another data set. So I want to create a data set out of those results and use those in other places, especially when I'm running code that is unsupervised. So that happens a lot. I'll run a script that I've written in SAS, and then what I want it to do is I want it to run unsupervised. And so what outputs to the screen is not important to me. That is useless. I actually want that data to go into a data set, those results to go into a data set. So in other words, output becomes data. And to do that, I'm using the ODS output table name equals option. And so that's taking the values from whatever I'm doing so I'm just wrapping, all you have to do in ODS, as you'll see here, is on the left-hand side, is I'm wrapping my analysis, right? We all know what a procreg is, right? It's a regression analysis. I'm just wrapping that procreg in ODS tags, okay? Oof, where's the SAS police? I did not close my ODS, I apologize. So I'm just wrapping it in ODS tags. So I'm saying ODS output parameter estimates equals CAR underscore PE. So I'm creating a data set called car underscore PE. And I know, now one thing you do have to know, and this comes with some experience, and also you can look this up in the documentation very easily. Every proc has different output that you can pull out, okay? So in this case, a proc reg has output called parameter estimates. So when you do a regression, these are the values that are statistically significant, right, for you stats nerds in the room, right? So here I'm doing a proc reg on sashelp.cars, and I'm trying to see which variables are statistically significant to model MSRP, and is it horsepower, MPG city, weight, and so on and so forth. And so then I just go ahead and output those results. But then notice what I'm doing on the right, is I'm actually processing, I'm just creating a data step, a new data set called car underscore PE again, but I'm only keeping it where they're statistically significant. So instead of just outputting the parameter estimates on the screen and going, oh, what are my p-values? Okay, are they lower than 0.05? Okay, these are the ones that are statistically significant. I'm actually outputting the results to a data set, and the only ones that are in the data set are the ones that are statistically significant. So I just use procreg as we normally would. There's nothing special about that procreg statement, but I'm taking the results from that statement and I'm holding it, I'm actually creating a data set with those results, which is pretty powerful. If you think about some of the procs we use, I mean, think of what procunivariate could output for you. lots of really helpful data. So I encourage you, instead of just using ODS to make things look nice and create pretty output, to actually use the power, and if we all know, depending upon your licensing, you also can output things to Excel files, you can output things to PowerPoint and all these other output sources as well. But I'm not doing that, I'm just outputting it to a data set. So this is what I have. So the top output is just printing the results. So that is the data set that is created when I output it using the ODS. So model 1 is just the default model name that ProcReg creates. Dependent variable is MSRP. What is the variable? What is the parameter estimate? And all the other p-values. So you notice weight, the weight variable, is not statistically significant. So I don't want that. That does not have any effect on my MSRP, the weight of the car. Okay, so I want to get rid of that. So in my program that I wrote, I just said I only want to keep it where prob-t, or the p-value, is lower than 0.05. And you'll notice I've now created a new data set. So that's really, really helpful, again, especially if I'm creating a piece of code or a program that runs unsupervised. I've scheduled it to run. I don't care about the printout. It doesn't matter to me. I want to use the actual values in a subsequent step that I'm writing or in another program. That comes in really, really handy. So I abuse the heck out of ODS in that way. It's very, 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 very helpful. So what we saw today is we've used a few different kinds of simple parts of the SAS programming language to group logic, to handle state management, to kind of handle metadata, to do a little bit of variable iteration, use in-memory lookup, and to do some programmatic output. All right, thank you.
Thank you, Michael. Really appreciate it. So we are going to jump to our next presentation, and I'm going to multitask while I am talking to you. If you have any questions, then as we have time at the end of each presentation, you can come up to the microphone and ask questions, but I also encourage you to stay to the end for our 30-minute reception. The presenters are going to be there. Ask them questions, pick their brains, ask them about their user groups. That's what they love to talk about. So our next presenter is Nancy Brucken, and she has been a SAS user since the ancient days of version 5 on a mainframe, working mostly in the that's right, working mostly in the pharmaceutical industry. She is the current president of the Michigan SAS User Group, a member of the PharmaSUG Executive Committee, and has presented at local, regional, and international SAS conferences. So, Nancy, thank you so much for presenting, and take it away.
Thank you for the invitation, and this is going to be a wow. I haven't even said anything yet. So, this is going to be a sort of very short look if it doesn't show up on the screen. Let's see. Go to sleep. You see, there's nothing weird in there. All right, perfect. Thank you. Yeah. So this is something. This will work in SAS 9. It'll work in VIA. It probably works on SAS 5 on a mainframe too, if there's any of those still around. But it's a technique that I picked up over the years because, yeah, we deal with all sorts of types of data in the pharmaceutical industry, and there's very strict requirements as to how we're supposed to display it. Statisticians are picky, and so it's just something I've come up with over the years to avoid having to hard code like lots of formats in my programs. So there's me. I always put in that little line at the end just to see if anybody catches that. So you can talk to me about it afterwards. Those of you in certain areas of the country will recognize the reference immediately. So, yep, in enemy territory. So this is what we're going to cover. I'm going to set up the problem, and then we'll look at a couple different ways of solving it. And the crescendo here at the end is sort of like what I think is the best way to do it, that requires the least amount of maintenance and gives you time to like do other stuff that's more fun than formatting your output. So this is the problem. Okay, we have to produce in clinical trials tables and tables and tables of output. And for those of you not in the pharmaceutical industry, what we call a table is what most of the world calls a report. It's just a report of something summarized in our data. And we have to generate a lot of these things. And many of them display univariate statistics, univariate summary statistics on our data. So we'll show min, max, median, mean, standard deviation. And one very common example of this is we've got to generate tables of lab results, which are collected over time. So we're doing a lot of, univariate summary statistics on lab parameters that are collected by visit for patients. And again, statisticians are picky. They want to see these things formatted in a certain way. So we've got data coming in that looks like this. And each of our lab tests, comes in measured at a different level of precision. In this particular example, we've got hemoglobin coming in as an integer. We've got WBC values coming into 1 decimal place. We've got calcium coming in at 2 decimal places. We've got ALT as an integer again. So you can see that the raw data precision varies by parameter. And the summary statistics have to respect that variability because, as you'll see in just a minute, we've got, again, requirements from the statisticians on how they want to see this stuff displayed. So we've got an output table. This is what we need to produce. For each of our parameters, we've got to show univariate summary statistics by visit. And notice here that there are sort of, a little bit of an indication of how these things are supposed to be formatted. But again, the display precision actually needs to depend on the number of decimal places there are in the raw data. So how many decimal places we display in the output is driven by how many decimal places are included in the data that's collected. And also it depends on the summary statistic being reported, because as you can see here, mean looks like it has 1 decimal place in this case, and I've got standard deviation out to 2, and min and max are integers, at least for this particular parameter. So, and I've got rules now given to me by the statistician that say, hey, for the min and the max, I want to display those with the precision that they were collected at. With the mean, I need to add 1 more decimal place. With standard deviation, I've got to add 2 decimal places. So, what do I do? And the problem is, well, I can run, proc means, I can run proc summary. There's lots of ways I can get those univariate summary statistics, but they don't preserve the raw precision of the data. SAS will give me as many decimal places as it can give. And, hemoglobin out to 15 decimal places is not something that anybody really wants to see. So it won't fit on my table, for one, there's not enough physical space. So, the SAS procedures leave the display precision completely up to the programmer, which, that can be a problem, right? It means I've got to do something about this. So, there's a couple of things I could do. I could hard code the precision. I could say, if it's ALT, I want to display an integer. But, lab data changes over time. Sometimes the lab runs assays that you didn't think they were going to do, and so you get more parameters than you thought. Sometimes the protocol changes midway through, and they decide they're going to drop some things, or worse, they're going to add like 10 more lab tests. And maybe the statisticians decide, there's a couple more that we didn't think we were going to collect, but now they've shown up and we've got enough subjects with data that we want to display these on the table too. So my specs may be changing. So if I hard code all this stuff in my program, every time we get a new shipment of lab data, I'm going to have to go in there and adjust things. So I really don't want to do that. I mean, it's job security, but I've got better things that I'd rather be doing. So, if I've got a large trial and a lot of data and parameters that change regularly, this is really unstable, right? This is not a good maintainable method. So I really don't want to be coding, if parameter equals ALT, then, display results to this precision. So, here's the problem. Then I've got at least 25 lab tests. So what can I do that I'm not hard coding all these things in there? So stay tuned. Here's solution A. And I can write a macro loop, and I can specify the precision exactly for each parameter, and then I'm just writing my code once, right? And I'm going to run it multiple times, and I've got full control over the display. I know exactly how many decimal places I'm going to put out for each parameter. But if I'd run this and call this macro for each lab test of my data, huge for the pharmaceutical industry is 10,000 records in a data set. I mean, things are changing, with wearables and all sorts of other ways for collecting massive amounts of data per patient. But historically, our large data sets are what many industries would consider tiny. But lab data is an exception because it's not that unusual to get a 10,000, 100,000, million record lab data set for a study. And if I am processing my lab table so that it runs, parameter by parameter, makes an entire pass through the data set for every lab test, that's going to take like all afternoon to run. And I'm spoiled. I'm used to my programs running in seconds. So I don't really think this is a good solution. I've got to make a pass through my data set for every lab test, so it's going to bog down if I've got a lot of data. And if I get a new lab test, I'm going to have to make another macro call. So that's not really self-sustaining here. So looking at another solution, I could do by-group processing, right? That's now a step ahead. I can use some if-then logic and assign my formats and run my table by lab test, and I can get my entire table out in one pass through the data set. But I've still got that if-then-else in there, and as Mike was talking about, if-then-else's a lot of times, require a lot of maintenance. Your data changes, you've got to do something different. And again, if I've got, changing lab tests, every time I get a new set of lab data, I've got different tests. Again, I'm going to have to update my program every time I get a new data cut in. So what else can we do? Well, here's another method. There are a lot of companies out there that have external files where they list all the lab tests that they've encountered, and they have information like standard units and display precision in there. So I could, if my company has done that, I can take one of those tables and merge it with my lab data by lab test, and that'll give me the display precision for most cases, in which that data has been seen, and it's still a single pass through the data because I'm just going to merge my lab data with this table, and use that to generate my display formats. And hopefully I've got everything in there that I need. There's not a new lab test that's come in. But somebody still has to maintain that database, right? So if I get the lab performs a new test and it's not in there, somebody's going to have to go in and update that table. So it's better. I don't have an if-then-else, and somebody else may be maintaining this for me, But it's still not quite, not quite completely data-driven. I can't just, point at my data and go home. So here's what I think at least is a better solution, and your mileage may vary. You may have some other way you've solved this problem, and if you have, I'd like to hear about it, because I'm always out for good solutions here. But what I decided to do on this was I built a intermediate step here that took, made a pass through the data and determined for each lab test what the maximum level of precision was in the data itself. And then I used that information to build my formats. And then I applied those formats to the summary statistics and generate the table. So this is completely data-driven. So if I get a new parameter, so what? I'll pick up its precision from the data. And there's no manual updates required here, because my code will take anything that comes in. So here's some code. There's that step, and I've got an input data set here, somewhere down, right here. And I'm going to build my lab parameter table. I'm going to pull off the parameter name, because obviously I need to know what the test is. And I'm going to pull out the maximum length of the value, and I'm going to pull out the maximum number of decimal places, and process this by lab test. So just a little note here: if I've got integers, then there's no decimal point on an integer, so my integers have a maximum number of decimal places of 0, because I don't want missings in there. That'll cause problems. And then I can build the formats off of that. So I'm going to, oh, sorry.
She's so good. She got
Yeah, sorry about that.
you went to
Yeah, that's what happened. Yeah. Let's see. Yeah, no, that's where I was. Okay, sorry, wrong. I was aiming for the pointer and got the forward. So yeah, so here's my data now. I'm gonna build some some variables containing formats in here, and I'm gonna take the maximum length, and for my mean, I need one extra decimal place beyond the collected value, and that's going to be 2 extra spaces in the length because I need the decimal point and, that extra that decimal place. And then min and max are going to be at the collected value, so I'm just going to put out what I got in, and standard deviation is 2 decimal places beyond what was collected, and I've got to allow then that extra space for the decimal point. So what these are then is these are numeric formats. So I'll end up getting like a 5.2 or a 4.1 or something like that in the mean format, the min-max format, and the standard deviation format variables when I'm done. And I will get a data set that hopefully looks something like this. So for each of my lab tests, I've got the maximum length, I've got the maximum number of decimal places in the collected data, and then these are the formats that I'm going to use to display my output. And all this is completely built off the data. I didn't hard code anything in here. And then if my collected value is an integer, I do need to add. If my collected value is an integer, I do need to make sure that I add extra for a decimal place, extra space for the decimal place and the decimal point. Okay, so this is what I'm going to use then to format my results with. And then here's how I can apply my formats to my summary statistics, and I've got arrays in there, Mike. So it's a really, really handy way of associating the formats with the summary statistics. And yeah, so I'm gonna merge my original data with my my formats data set that I just built by parameter, and set up some arrays for here's my original values coming in off my, for my proc univariate or my proc means or however I generated the summary statistics. And then here's those formats that I built just now from the data. And then these are the character values that, formatted display values. I'm going to turn them into character variables. This is what I'm going to display on my output. And then I'm just going to make a loop here and use the putEn function, which is really handy, to put out each of the stats values using the format that I've created off the data. So that's the little trick right here that makes it all happen. And that putEn function then associates the correct format with each of the summary statistics. So my final output then, those character variables are going to contain summary values that are correctly formatted, and the level of precision is going to be based on the lab test. My output's ready for my tables. I don't have any more post-processing and nothing else I need to do. And if I get more lab tests in, I just run them through the same routine. So there's no code maintenance involved. I get a new lab cut, just run the program again, and unless anything really, really weird has happened, it should work time and time again. So, in summary, data-driven programming in general, really reduces a lot of manual effort, makes your programs more robust. Get the precision off the data and not from hard-coded rules in your program, because hard-coded rules break. And in this case, my new lab parameters were automatically formatted correctly, and I didn't have to do anything. I had a manager many years ago who said the best programmers were lazy because they got the machine to do all the work for them. And I think this is a good example. So there's my contact information. I guess this was a little shorter than a half hour, I'm sorry. But, so, thank you.
Thank you, Nancy. All right. Okay, we have one more presentation, and then we're going to go to break. So we're going to switch around the computers, and whoop, too many papers flying around here. And then we'll get started. So I'm going to do a quick survey while we're working on the laptops. How many of you have attended a SAS user group in the past? Oh, wow. Okay. I'm seeing some hands. Sir, which one have you been to?
My first one was the Wisconsin-Illinois SAS user group, which was appropriately named WISAS.
Yep, appropriate. Yes, they have. Yes, it is Wilsug now. Anyone else? Which one have you been to? Yep, you, sir.
Do you know, is there any videos?
Wuss, yep, absolutely. Yep. Anyone else? In the back, yes. Notsog? All right, that is right here in our backyard, North Texas SAS User Group. So, all right, I'm going to introduce our next speaker, Louise Haddon. And if you have not met Louise, she is also known as the woman with the SAS tattoo. So, it is on proud display. Louise, she has a fascinating background, and I could tell you about her professional background, but what I'm going to tell you about is that she has presented over 200 SAS-related papers. And this phrase is going to resonate with some of you, and some of you it's going to go whoop, right over your head. Her first conference was SUGI 1996 in San Diego. Anyone remember SUGI? Went to a SUGI? All right. So in addition to that, not only has she presented numerous times at SAS corporate events like this, but she presents at regional user groups, local user groups, and in-house user groups, not to mention countless one-day events for who knows around the U.S. So if you're interested in learning what the difference is between regional, local, and in-house, come talk to me either during the reception this afternoon or in the Innovation Hub. I'm going to be at the SAS User Engagement booth, and I would love to tell you all about the different aspects of our user groups. So, Louise, take it away.
Hi, everybody. I'm going to be talking to you today about out-of-the-box data visualizations with SAS. And it's going to be an introduction to what ODS graphic statement can do for you right out of the box, not necessarily with SG procedures or StatGraph or anything else, but just by itself. So, yes, I did start at 1996. I used to put in my bio that I had been using SAS since the Earth was a primordial soup. But then I decided that that dated me. So now I just go back to the real date and, and leave it at that. In the beginning, a punch card, a SAS, and a geek walked into a bar and Nirvana was found. Seriously, where did ODS graphics come from? Creating graphic outputs with SAS software has been the subject of many SAS paper over the years, including my own. And SAS users have a lot of options when it comes to graphs. So there's SAS Graph, there's JMP, there's various modules such as IML, the more recent SG procedures, all of which I've used. And then when the output delivery system first arrived, it drew on a number of earlier developments. And then they introduced a pre-production version of ODS graphics, and that was a new graphic system that's template-based. And that followed in ODS's footsteps. So the new system was originally part of SAS Graph, which is a separate SAS product, but in order to meet more users, it was moved to base SAS, and that's where it is today. So that's why you can run ODS graphics right out of the box and get some really usable output. So in ODS graphics, many statistical procedures could produce one or more graphics depending on options within the procedure. And that's true. When you look at any statistical procedure, there are hundreds of options that you can use, different kinds of tables get produced, different statistics, et cetera. And SAS has done the hard work of figuring out how to visualize all of those statistics and combinations thereof. So, and there are many ODS statements in base SAS. Everyone has probably used ODS HTML, ODS Excel, et cetera. There's ODS output, and there are way too many to describe in a 40-minute session. But for now, this presentation is going to hone in on the ODS graphics statement and its many wonderful options, and why you want to add some of these ODS graphics to your SAS toolbox. For example, I work right now with patient safety data, which is a huge collection of adverse event data. And there are thousands of data elements, and all within different health systems. And so my analyst said, how can we get through this mess of data and try to explore these data elements? Because one of the things that we do is create dashboards for the general public. And you want them to be actionable. You don't want to have things that don't make sense. So we needed a way to really run through a lot of different graphics without a lot of work and without a lot of separate individual coding. So that became the challenge, and that is the case study that I'm talking about. That data is published in multiple dashboards by event type. It's a public-facing database, and we needed a really quick way to determine what is relevant and safe for publication, because we also had PHI and PII in the data. So for that reason, and I was really glad to see Michael talking about this, we're going to use the SAS Help Heart dataset that is based on the Framingham Heart Study. And the data contains lots of demographics, medical data, and risk factors. And I added a few others just for fun, and I will not reveal any PHI or PII in this discussion. So what is ODS graphics' place in the SAS graphics continuum? So you notice a little ODS graphics with the graphics coming out of the box. That's like a little bit of fun. Is the ODS graphics statement even necessary? And the answer to that is it depends, because ODS graphics is enabled by default in some systems. For example, Enterprise Guide and SAS Studio will have this by default. There is a caveat to that. We'll get into that in a little bit. It's not required for SG procedures. They have their own method of output. However, it can enhance your SG procedure output. It is required if you are going to use statistical procedures that are creating a bunch of different plots. If you don't use the ODS graphic statement, pretty much nothing happens. So I used to go to many talks by Cynthia Zender of SAS, and she always used to talk about the ODS sandwich. So most of the ODS calls that we can make, or commands that we can make, start with one at the top, turning it on, and then one at the bottom, turning it off. And in this case, the ODS graphic statement has /options. So I like to think of it as, the ODS on and off are the two pieces of bread, and the guts are the options. Noting that we do have to have the statistical procedures or an SG procedure or something else as the guts, as well as the options. So basically, there's no exception to that particular need with turning it on and off. And so there's a lot of handshaking that goes on between the pieces of bread and the protein. I try to be politically correct. That is bacon, but it could be soy bacon. Anyway, there's a lot of handshaking between the SAS style and graphic templates, the procedures themselves, and ODS graphics command. So in this section of the presentation, we're going to talk a little bit about some of the options and some defaults that we can find. So your environment matters. Where you're running your SAS code matters to ODS graphics. For some SAS instances, you don't need to use the ODS graphic statement at all. It's included as part of your startup in environments such as SAS Studio and SAS Enterprise Guide. In all SAS instances, if you do not specify options in the ODS graphic statement, SAS runs with default values, which may or may not be what you're looking for. And I will say that it looks fine. The default values look great. You just may want to add a little pizzazz or do something a little bit differently. So some options may work differently in different systems, such as the default location for generating the graphic files. So your output destination matters. It matters to ODS graphics even if you aren't writing to a typical destination such as RTF, PDF, but especially if you are. In some SAS instances, it's not necessary to use that statement. And if you don't do that specific thing. So where the SAS procedures you are running matters to ODS graphics as well. Traditional SAS statistical procedures do produce different graphic outputs, as I mentioned before. The SAS documentation on statistical procedures will become your best friend. In order to control the output, you need to understand what graphic is produced by each procedure you use. And within each statistical procedure, there are often different options for each graphic type, which override the ODS graphic statement. If you're running SG procedures, there's a whole set of different behaviors, but we're not going to talk about that today because it would take me forever. And lastly, any SAS templates or GTL that have some options that will override the ODS graphic statement. Nonetheless, simple is as simple does. The nice thing about ODS graphics statement is it can be incredibly simple and bare bones, and at the same time, incredibly complex and detailed. So this is how it works. I always turn the ODS graphics off, just in case there's another session that has some options that you really don't want to have in your next session. Then you start up with ODS graphics on. The on is actually optional. You can just say ODS graphics and then /options. And then your procedure has procedural options that will affect what kind of output objects are created, and plots and procedural statements, and then options on those, and then options on plot requests, etc. So it can be very complex, but it also can be incredibly simple. And the ODS graphics off to start with. And another layer is bringing in, if you go out to a destination such as ODS HTML, and you put on a style, there are defaults that are controlled by the HTML destination, and they're defaults created by whatever style you happen to use. But again, just the ODS graphics, turning it on, and then your procedure, and then closing it, and then closing the HTML. We'll see an example of this later on. So here is a program, it's a vanilla ODS graphic statement where we're simply going to turn it on and rely on the defaults, HTML as a destination, etc. So this creates tables and chi-square for a crosstab. This is Proc Survey Freak. And by a group of variables, by one variable, by a group of variables in the HART data set. And most importantly, plots. We request plots equals all, which is a shortcut. If you don't know what plots are supplied by a stats procedure, you can just say stats equals all, and it will attempt to produce all stats, all the plots for you. And it, as you can see down in the bottom, it says writing HTML body. That is just a default statement. So this is the so-called print output, and it's a two-way table and a chi-square test. And as you can see, this is the default HTML style is being used with the blue on blue. And here's a plot. And this happens when you have a crosstab. You get a two-way plot, and that is, so it has given you, this is a frequency plot, and this is the default appearance of it with the two rows, because there are two different values. If you had a variable with three values by another variable, then it would be three of these little plots. But that is what happens with that kind of setup. And then this is the second plot that is created automatically for Survey Freak and two-way crosstabs, and that's a mosaic plot. This looks kind of like a stacked bar, but it really isn't. It just happens to be that way because the width and the height in mosaic plots are both controlled by the data. So you can get a very different thing, and we'll see an example of that in a little bit. And then here is, if you're running in Display Manager or anywhere where you can see the results window, you can see that the table and plots are all lined up along the left there. And then if you click on one of those plus signs, then it also is going to drill down a little bit, and you'll see what's inside of those folders. This is kind of like a special storage area for SAS. This is where SAS keeps all your kind of plots in motion, unless you specifically write the output elsewhere. So you can see that there's a cross-tabulation table, which we saw, the weighted frequency plot, which we saw, the mosaic plot, and we also did a chi-square test there, and that gives you another table there. And just a point of where this stuff is stored, it's not in your folder It's actually in this very long string there, and that's a temporary holding spot that SAS uses. So now we're going to talk about what options we can tell SAS to do with the objects, and then show the effect of those options. And here are some of the options on the ODS graphic system. There's a lot of them. I don't expect everyone to read through them, but just to say that there's a lot of different ways that you can manipulate ODS graphics. Very easy, and you don't have to use them. You can just take the defaults that SAS has, and that is a perfectly valid thing to do. But if you do want to play, here are some types here and some defaults. So you can set the width and height. That can be in pixels, it can be in inches, or anything. If you want to create an image that is 8 by 10, you can do that. And it will create that output image exactly the way you want it. If you want to have tooltips in your image, you can also do that. You can have image map. The default is that it's off, but you can turn it on if you want to have tooltips appear in your output. And scale is the scale factor. So the default is on, that is when the graph is changed by using width or height, all the graph elements kind of change with it. It's just keeping things proportional. And so that is also a useful thing. I almost always use the width and height when I make graphs. Okay, another really important one to me is image name. If you don't specifically name your output in ODS graphics, you are not going to get what you would think. You'll get freak plot 1, freak plot 2, etc. You can also change the image format. In most cases, PNG is my favorite, but there are different destinations which will create different types of image formats automatically, and you may want to override them. You can't always, but you can try. And that is a nice thing to be able to do if you want to do scalable graphics or something like that. So the default image name is the SAS ODS graph name, which is like counterplot, freak plot, etc., mosaic. And the default, as I said, was ping. But it does vary. And SAS automatically appends a number to the image name if created in the same session to prevent overwriting. This can be really annoying. You can have like 400 graphs named the same thing, only with 1 through 400 if you keep trying things. So my suggestion, and I almost always do this, is to reset the index so that you don't get that happening in your thing. And more importantly, just use an image name, and you'll get that. Output control, limit the observations used in plots, and that's maxobs. Index adds an index. You may want to say, I am going to create 5 images. They're all, and they're going to be named the same thing 1 through 5. You may want to do that. And so that allows you to turn that index on. And so the output format controls the format in some destinations, but it's dependent, largely the default is dependent on destination. Okay, and so for the statistical procedures, there's also some, this is just a quick list of statistical procedures. So they produce numerous procedures that do generate high resolution ODS graphics automatically. And this is just a sampling of the procedures that are most commonly used. And these are the statistical ones. There's also some in ETS, in QC, and in the SG procedures. And there are many in base SAS, such as the survey procedures, ProcFreak, et cetera. Again, the SAS documentation for procedures is going to be your best friend. It'll tell you what plots are available for procedures, if any. Now, how does it work? How does the ODS graphics statement work with the stat procedures? Each stat procedure produces its own list of plots. Some plot types overlap across procedures, others don't. Some stats procedures create graphs without using the ODS graphics statement, others do not. And the SAS documentation is invaluable in telling you what does what. Presented below are some common plot statements. And one of the main ones is on plots. So I did talk about plots equals all, which gives you all available plots. Mind you, sometimes your data may not suit some of the plots that a procedure may generate, and SAS will tell you that, and it won't make it. Or you may want to suppress the plots, or you may want to just say whatever the default set is, because that may not be all, it may just be the same thing. And then, survival and so on. And it's by no means, a full list. It's just enough to give you an idea of what might be there. So one of the other things you can do is the layout and orientation. And that allows you to change the look of how the plots are laid out. So things like unpack, only restrict to specific plots. Overlay, you may want to overlay some elements. And paneling and control, that's like the number of rows in a panel. Number of columns, and by, panels by variable detergent. And then we go on to plot-specific sub-options. And that is things like plots only, will only show you that plot, and it will, the effect plot allows you to do slice bys and plot bys, so you can pick which variables control what. And you can also do some access control, like orient equals horizontal, orient equals vertical, flip in some procedures. And then there's display options, like CL, like confidence limits. Do you want the confidence limits to show? Do you want to show counts and smoothing and labeling? So all these things can affect the appearance of your ODS graphics. So let's put the ODS graphic statement through the paces. This first one is I've turned the ODS graphics off, and I ran SurveyFreak, and I turned ODS, and I did not have a plot statement, and I turned HTML off, but I didn't bother. But basically, the results window over on the right side this time shows that we didn't make any plots, and that is because we didn't ask for the plots in the statistical procedure. So this is a second one with the ODS statement, and with the ODS graphic statement and without a plot statement, and this one does produce it. So, and then the next one, and that was because of the ODS HTML statement. Now this one I'm using with ODS HTML, with ODS graphics, and without the plot statement. And this is just showing that the output went to the output and the HTML output, so that output goes to your directory. So once you have that HTML destination, it automatically went to your directory. And the differences don't really stop there. The listing table has defaults for the listing destination, and the file that went to the HTML destination with SAS applied destination style analysis has the defaults for the style definition. So you see the exact same information looking totally different, output by the same thing. Okay, I'm sorry. Okay, you can see that this is like a club style sandwich. So putting that HTML in, so the extra layers of bread can really provide you with a lot of options in terms of your graphic appearance and their location. So this is with HTML, ODS HTML, with the ODS graphic statement, with the plot statement. And here you can see that the graphics are created, and we see two new object classes, and that's the weighted frequency plot and mosaic plot. Each of these objects has two versions, one for the usual graphic, and you can see that there's one with a question mark on it and one with a little image in there. And one is contained in the HTML, and the other one is wherever the GPath is directing your output. So the GPath is in the ODS HTML statement, and that is what tells it which folder to put things in. And here we see a list of the graphics that happen in your folder on the far left, and then the two different graphs in the different places. So note that the HTML file style takes precedence. So adding in some options. Here we go with style template, ODS graphic statement, plot statement with reset index equals index, which means the number is reset, and then image name with border off, image map equals on with supplying a particular plot, freak plot. And the usual suspects are produced. So where are the changes? Here you can see that the plots, so at the top, the blue shaded ones there, those are the ones that have been named. And we've named those plots, and you'll see that they're numbered. The top one is numbered with 1, and the bottom one is numbered with 3. And the two graphs that it corresponds with is the single, the one-way frequency right there, and then the two-way frequencies right there. It's because that's two graphs in one that it's actually named 3. So that's why the 3 goes there. So SAS kind of names it it just sort of names every graphic it creates. Even if it creates two graphs on one page, it names it according to the longest, most numbers, highest number. And because the analysis style is in effect, we get that yellow and green color scheme, and there's no box around the graphics because we used border equals off, and we've specified that we only want the frequency plot. We don't want to see the matrix plots. And we also specified image map equals on, which gives us the hover text when mousing over areas. And you can see that. I actually had to take a picture of that with my phone and stick it on there because I couldn't do the screen capture with it on. So, but it does gives you a lot of information automatically when you mouse over the areas. Okay. So then I did, just to show how you can do it, a macro so I can create individual named graphics so that I can get specific graphs out. And so this way I can get, there'll be things that are named with the actual name of the variables. So, I did, and so here's a little bit more on using the plot sub options, and that's going to be bar orientation and scale. And so this is that same frequency plot, but now we're fooling around a little bit with it, just saying, okay, let's do type equals bar, and what the orientation is. So you can do horizontal bars or you can do vertical bars. Your scale can be percent or it can be number. You have a number of different options. And this is just out of the box. Don't need to do too much other than to specify those types. And you can see the difference between these two is the orientation, and the second one has orientation vertical and frequency instead of percent. And then you can create a dot plot just by using type equals dot. And you can also, and again, this is a horizontal. And then this one is another bar, percent, and horizontal. So, and then we're really getting fancier here. This is this is bivariate, so we're using two variables, and so we have a freak plot, but now we're saying group by column, orientation is vertical, and here we're making a stacked bar and putting the group percent in there. And then here, the next one, this is the mosaic plot where you can see the width is changing, the width and the height changes. Which is actually, it's a very nice thing. And this is all automatic. You don't have to specify that you have the gradient range on it. It just comes out automatically. So in conclusion, I'd say I hope you've enjoyed seeing what you can do without a lot of SAS graph code, SG procedure code, or GTL code. You can get out there and do some really great quick and dirty exploratory analyses. And they can actually be used for reporting. And so this is a great time to think inside the box and getting your ODS graphics out of the box. And so you can contact me on the paper. The sample program and presentation is available. I have a GitHub up there, and I will put everything up there in my GitHub account with SAS Innovate 2026 in the folder heading. Any questions? Right, thank you.
Thank you, Louise. Let's see how we're running on time. It is time for a break. Yeah, we're a little ahead of schedule, so let's take a 10-minute break, get you stretching your legs, and then come back. We have 2 more presentations and our reception. So, see you in 10 minutes.
Thanks for having me. It's fun.
For the committee back in 2005 for volunteer section.
Oh, yeah.
Part of New York for a while. Yeah, it's insane. You just like in my head like.
It's fun.
Yeah, I do have the clicker. I have my own, so.
Well, I mean, $1,000 is a little bit more than I like to wink about. It's not like a dinner.
Yeah, so I'm glad thanks for calling me. I was having lunch with Chris, and my phone was on silent, and I was like, hey, someone just called.
I didn't expense this. I'm on my own dollar for this conference. So,
Yeah.
so that, yeah, would have been a lot.
Yeah.
I forgot I encrypted this one. I just didn't want to know to see my secrets. That's it.
When are you doing that?
I'm just wondering who do I have to ask to switch HDMI cable? Probably those guys are there, right? Don't worry. Okay. We still have like a 7 minutes. final check.
I've got you pulled up already, so you're good to go. Yeah, I had my still up when you plugged it in, so. Yeah, just microphones right there.
Yeah. So just need to plug in my mouse. Just just to work. Thanks.
Did he get you? That's yours, okay.
Yeah, I've got this flipper. Yeah, I've got the flipper. I've got all this stuff. That's my badge over there. Just need to remember to pick it back later.
Okay.
Yeah. Thank you.
All right, everyone, we're going to get started again. So the next presentation is by Bart Jablonski. And Bart is many things. He's a mathematician working and playing with data, an open-minded analyst and science enthusiast, a consultant and seasoned SAS professional since 2009, and a SAS teacher, not to mention an active member of the Polish SAS users group. But Bart is also the author, designer, and developer of the SAS packages framework. And best of all, he's not afraid to admit that he's a SAS geek. So, take it away, Bart.
Hi guys. So first of all, disclaimer, okay? So I'm from Poland. Polish is my first language, but my second language is not English, it's SAS. Okay, then there is Tech, R, bit of Python, Bash, and then it's English. So be gentle on me, okay? So usually when I say something like, look at this sheet, I mean spreadsheet, not bullshit, right? So please be gentle. I try to do my joke the best possible way I can. Okay, so the title goes like this: SQL and AvExpress packages, a tribute to my SAS rockstars. So first of all, this will be like only small tribute, not to all my SAS rockstars, but only to two of them. And if you're not familiar with the idea of SaaS packages, I will have a presentation about them tomorrow, like general overview. And for the Wednesday, I have this brain day session where I'll be talking with more details if you're interested and if you want to see them. And let me just briefly introduce myself so you know that I'm qualified to talk about SaaS in the first place, okay? So I'm doing SaaS pretty short because I started 2009, and SaaS 9 was my first SaaS. So, you know, I'm newbie in the SaaS world. I'm teaching SaaS classes at Faculty of Mathematics and Information Science at Warsaw University of Technology. I'm contractor, that the Jabłon is my company, and I'm contractor for Takeda. And thanks to them, I'm here. I want to say thank you to my manager who allowed me to get here during the working hours. And yes, you already know I'm a member of Polish SaaS user group, and I'm SaaS geek and SaaS freak at the level that if my wife wants me to do something, she starts like, data null, go do dishes, run, right? So that's the level. Yeah, so that's me. Oh, by the way, at the top over there, I'm not sure if do you see the red pointer? Yeah, there are some phrases, they are in Polish, so I want to sneak peek some Polish phrases for you during the presentation. So who's Bart? That's the question there. Okay, so rock stars. There'll be two of them. So my first rock star, I managed to meet in the real life. It was Dallas here in 2019. The other one, I have only a blurry image in my head. I never had a chance to meet him live, but I read his paper. And the first rock star, the one which I never had a chance to meet in real life, is Mr. Mike Rhodes, and the other is Mr. Rick Langston. When I went to his presentation during SaaS Global Forum in 2019, I realized from his first slide that he was doing SaaS longer than I lived at that very moment. Those guys wrote those beautiful articles first one named Use the Full Power of SaaS in Your Function Style Macros, and Rick wrote the other one, Submitting SaaS Code on the Site. And basically they introduced the ideas which literally can blow your mind if you realize how powerful and how beautiful things you can do using those ideas. So the first one was about concept named macro function sandwich. Do you know that you can write macros in SaaS? For sure you do. Do you know that you can write user-defined functions in SaaS? You probably do it too. But do you know that you can call macros inside functions so they will do stuff for you? So that's the first paper which it is about. And the second one is about introducing new super cool function named DoSubL, which allows you to create a side session within your main SaaS session, do stuff there, and then get back to your main session to continue with your work. So basically, you are able to run 4GL code while you are running 4GL code. Very, very interesting, very, very useful stuff. And whatever I'm going to talk about next, it's basically a way of me saying thank you to those guys for their work and for their contribution to SaaS community and to us. So let me present you two problems which at the first glance supposed to be unresolvable. That's the phrase, that's the word, is it? Yeah. Unresolvable in SaaS, but with help of those two papers, you are able to solve those problems. So, okay, first problem goes like this. So problem statement, pytanie pierwsze, that's in Polish, question number one. Problem statements goes like this. You have two data sets. They have merging variables, x and y correspondingly, so left x, right y, and they've got repetitive bigroups in both, so merging with repetitive bigroups is not exactly what we want to have here, but the question is, can we use SQL query inside a data step to combine those two data sets and then process the thing further? So basically, we have set up like this. So this is the left table. This is the right table. There's X, there's Y. We want to combine those two data sets over those variables here, X and Y. And basically the question is, could we write our SAS4GL data step code with this little extra SQL snippet inside to have it running, right? Is it possible to do something like this in SAS? So the result, counting the additional statements, like the sum statement, which sums up all the variables from A to D from those data sets and creates new variable T, which is sum of them, right? Create data set like that, right? So that's the question. Here we are doing like a Cartesian product, so with the where condition. So basically, we are doing here inner join over two data sets. So the question is, can we do something like that? And it's not imaginary questions, because some time ago at Stack Overflow, maybe you know that. Well, now with the AIs and language chat GPTs, people stop using Stack Overflow, but sometimes they still asking questions there. So there is a pretty fresh question from this year from Stack Overflow. Can you do stuff like that, right? One thing, you can do stuff like that if you are using ProgDS2. ProgDS2 allows you to embed SQL queries inside, but thing is, I don't want to use DS2, I want to use regular data step. Just for example, I want to combine two tables and then print out the result to the text file, right? And in DS2, you won't be able to do it, right? So that's the first question. The second question, a little bit different. So imagine that you've got a data set which has a bunch of string expressions like A and B or C, or A times B plus C, or 42 equals A plus B plus C. And basically A, B, and C are variables inside some data set have. And now the question is it possible, or how can I evaluate those expressions which are in fact text strings using values from A, B, and C in a graceful way that I can just run my code over the data set containing those values and get the results, right? So we have something like this, little smaller, simpler example. So our code, our variable with the text string is A plus B, A equals B, A or B. And then we have variables A and B with values corresponding to A and B. And we basically would like to have some magical function, let's call it evaluate, right? When you put the variable named code, so we take the text strings, and based on those values, we get the results, right? 17 plus 42 is 100 equal 101, or 1 or 0, right? Something like that. So is it possible? And again, as in the previous case, people were thinking about stuff like that for quite a long time. First article I encountered, which was discussing expressions evaluation provided as a text string, was the one from, I think it's NISAC 1990, the article, this one, but this one was based on macro language, so not just plain expressions like we have here, but rather macro variables. The latest one was from last year, FUSE conference in Hamburg, where Steve Prost was using the approach from the first article, from the Mike Roth article. And even me, myself, in 2019, I wrote this little post on SAS-L, the discussion list, which was titled Yet Another Reason to Love Hash Tables, because I used hash tables to approach this problem. Unfortunately, it wasn't graceful enough, because when the expression had syntax errors, the whole thing flipped up, so I have to figure out something new. By the way, during that discussion, I got a few other ideas from other SAS-L members. One was about, again, using macro language and translating expressions to macro language and then evaluating it, or the other one was using ProcLua, so using Lua language, but they also weren't, I would say, good enough, because we had to somehow translate the expression to the proper language, macro language or Lua language, and then evaluate them. And I wanted to have something which will be take plain SAS expression, evaluate, and return, right? So that was it. So over the time, I've created two packages. So the first one called SQL NDS. You can suspect what it does, and then the other one EvExpress. You can also suspect what it does. And basically, what are packages? Packages are those little tools that allow you to reuse your code in a convenient and easy way. And even if the code itself under the hood is complex and fairly complicated, you can share with your other friend or user for whom you created the package. You can share just a single file and tell that person, use the phrase load package and then go with the process. It will handle all that stuff for you. Like in other programming language like R or Python, where you can load package which does some job for you and you don't have to go through all the gory details. You can just use the stuff, right? It's like someone gives you a car, not ask you to build car from scratch. So yeah, how to get those packages. So as I mentioned earlier, tomorrow I'll be giving you all the details how to go there, but the tool to use packages is called SAS Packages Framework and is available under this GitHub link. By the way, both slides and the code related to those slides, let me see it for a bit, are already available at the GitHub page here. At this GitHub page. Jabłon, that's my nickname and the name of my company. So if you just type github.com/Jabłon, you will get to the place where both slides and the code is available. And here is SAS codes and snippets. All right, so also the framework is there. And SQL NDS and EvExpress are both available under SAS Packages Archive. So this is another GitHub repo, GitHub page when you can jump to that repos. And basically, you go there, you navigate to this place here, where was repositories. Here you click on it. It takes you to the list of repositories, and you can either pick up EvExpress or the other one, the SQL NDS. And basically, you go there, you download the zip with the package to your SAS, and then you can start playing with them. And how you do it in SAS. Yeah, okay. So it's very, very easy. First step for SQL NDS, you have to call macro named load package, which is one of the macros from the framework, and it will take that zip file and will load all the complexity of the solution for your SAS session. So you won't have to worry about how it's set up under the hood. And then inside your data step, you type %SQL, and then you put SQL query, and it will execute this whole data step with the SQL query inside it, step by step, using the technique provided by Mike in his paper. So for that paper, for that package, in packages you've got the list of authors and maintainers. So I explicitly put Mike Rhodes as the author because he was the one who invented the idea. I wanted to honor him for that, and I'm just a maintainer of this one. So when we run package like this over those two data sets, left and right, we'll get result which basically executes SQL natural join and then goes with the other steps of data step. So we have the table which joins. Here's just X and X, right? But that's X and X, not X and Y from the previous example, because I wanted to use natural full join to show you that there is something like this in SAS. And I also wanted to do it like this because one of the features of the framework is that when you run a SQL query, it prints the query you executed, you want it to be executed, and then it also prints the explanation how SAS understood your query. And also here you see all the steps under the hood, and this one uses user-defined views for SQL under the hood. So there is no magic. It's very standard thing, but gives you this nice functionality. Okay, it's not a silver bullet. If you want to execute pass-through to external databases, it won't allow you to do that. You can just work on SAS dataset, both base and SPD, so Scholarly Performance Data Engine. So that's how it goes. And the second one, okay, so again, you have to load the package to your SAS session. So you basically type load package and name of the EvExpress. So evaluate expression, right? That's the short, right? It's not about train. And you've got the variable with all those weird texts. There is a text string with expression for every line, and there is basically 3 variables which we want to use because they are in those expressions. And you can use the EvExpress in 2 ways. Either you can use a macro, which basically asks for the name of the data set to be processed, ask for the name of variable with this text string for expressions, and you can also optionally give the name of the output data set. And when this macro is executed like this on this data set, you will get answer which looks like this. So 2 variables are created. One is by default called error check, so it checks whether the processing of this expression was okay, so there were like no syntax error, stuff like that, and it gives you indicator. So if it's 0, this means that there were no errors. And then it gives you the second variable named results with values calculated from those expressions against these values. So that's the one way. And the other way is by using user-defined functions. And here, in this case, there are 4 of them, but I'm showing you just the first one as example. It's called EvExpress, and basically inside that function, it expects the name of the data set, it expects the name of a variable which contains the text to be evaluated, the expression to be evaluated, and it expects 2 additional values: the name of the data set where the variables are located, and the number of observations from that data set, because we have to tell, okay, evaluate this expression from this data set, from this particular observation, right? We need to tell SAS where to take data from. So this gives you a pretty nice flexibility that you can use expression from one data set, and you can use other data set as the input for the evaluation. And this function is for numeric expression. If you want to evaluate one with the character expression, you have to add C at the end. And there are 2 more with letter Q, which means quiet, because basically this one, when you run it and there is an error in the expression, this error will be printed in the log. And if you want to make it silent, you just use the Q version for quiet. So that's more or less how it works, right? And here, in this case, you've got the same evaluated values here, but in the variable value, like we put it here. And this behaves pretty graceful. That's right, pretty graceful, because if the expressions are incorrect, you can suppress printing errors, and just you will get like empty value or missing value if the expression is incorrect. And again, as I said previously, the first one wasn't silver bullet because external databases were not supported. In this case, this one is not bullet train, I would say. It's not very speedy, but it's also not that bad. When I did a test on my laptop for 6,000 expressions, it used 18 seconds. So on one hand, it's pretty slow, but on the other hand, it gives you the expression evaluation for 6,000 observations, right? And especially that it uses under the hood the do sub L function, which basically creates a brand new SAS session, do the evaluation, and get back to your main session, and have to repeat this process 6,000 times, right? So not that bad. How we going with the time? Fine, okay. So here's the short list of papers and articles and discussions where all the stuff was described or talked about. And now I switch to the slide with logo, and I try to show you a live demo. So it's not just a nice picture, you know, that little meme where there is this table, two girls sitting next to the table talking to each other, and the one holds a dog above his mouth, right? And they usually say, okay, when marketing describing the solution, and the dog is IT, which knows that the solution is physically impossible, right? So basically, I want to show you that it is physically possible to go with this. So let me do it the way I do with my students. So I open my laptop, I open my SAS session, sorry, not this session here. You can see I'm using base desktop SaaS, and in this case, I already have those two packages loaded here and here. And as I said, both the code, which I'm showing you here, and those slides which you just show, right, they are already available in the GitHub. If you go to SaaS code snippets, there's a bunch of stuff inside, but one of them, or two of them, are the Innovate presentation and Innovate SaaS code. So let's go with the code for a sec. So SaaS session is here, right? So I skipped the commented part, which basically tells you how to install the framework and how to load packages to your session, and I just go with the real data. So we've got dataset named left, we've got dataset named right. As you can see, for X variable, A is doubled, B is doubled, and here in the second case, B is doubled. So basically, merging would not give us the result of Cartesian product of every value of every value. And here with the SQL NDS package, we can write it this way, that we take left, we naturally join it with right over the X variable, and then we do the sum function over all numeric. In this case, the merging variable is character, but A, B, C, and D are numeric, so we can easily write off numeric, and we will get the sum of all of them. So let me first create those two data sets, and let me share you the log. So, oh, sorry, wrong button. So you can see both data sets were created, right? There are no errors in the log. By the way, it's good to have a snippet of code and a joke in the good programming presentation. So now let me do the joke. Do you know what's the difference between SaaS user and SaaS programmer? After running a snippet of code, users go to output window, programmer goes to log window. Paul Dorfman, he gave me this joke. Okay, so we've got the data sets, and now let me show you that the SQL query inside the data step is doable. So I hit F12 because I have jump to log hidden under F12. And now if you look, sorry, again, wrong button. If you look here, you can see SaaS showed the code which I pushed to the SQL macro, and then in the red lines he prints out the translation, and then here you can see this line, and this is the part which the package is doing. It creates you a dedicated view, SQL view, which is then used by the data step under the hood. And the result, let me zoom in, and the result is here. So you can see we've got Cartesian product of B, so 2 times 2 is 4, right? So everything is calculated and looks nice. And now the other part, yeah, there is another example with the text file, which I just mentioned during the ProcDS2, right? So you can do SQL queries inside ProcDS2, but you won't be able to print the result directly to the text file. And with DataStep, you can do so. That was the example why to use DataStep instead of DS2. And now let me go to FExpress. So here's the input data set. So we've got the bunch of expressions here. We've got the variables x, y, and z, and those variables are here in those expressions, right? And we want to evaluate values of those expressions against this values here. So one option would be with the FExpress DS macro, and the other is with the FExpress function, right? So if I run it like this and go to log, you can see that here there's clear green log, no errors, no problems. So input data set 6 variable, 6 observations, output data set 6 observations, and the data set created when I print it, will look like this. Right, so we've got this new calculated value variable created. And now let me show you that it can behave gracefully. So let me do it like this. Here I will change the little line here, and our first expression won't be a comparison to a constant, but basically will be comparison of two variables, right? Variable C and variable A. That's how SAS would interpret this little snippet. So basically when I run it, it will throw an error. Let me go here. So you can see there is an error message. Variable A is uninitialized, but the dataset went through and ended and created result. In the output, if we now run this result, you will see that for the first line, because this expression was not correct, because there was no variable A to use in the expression, we've got empty value. But now if I add a Q here, like quiet, right? And now I run it, you can see that all the expressions were evaluated, dataset with result was created, and basically the result is exactly the same as the previous one, right? But basically we have graceful execution of the code. So yeah, those two packages I'm using them on daily basis, not only for fun. They are tested and they are production ready, so you can use them for sure too. And first and foremost, those two packages are my tribute to Rick and Mike. Their work is brilliant, and I wanted to honor this work. And the third reason, because first reason is I'm using them on daily basis. Second reason, I made them as a tribute. And the third reason, they are my two little favorite demo packages, which shows you how you can use how you can utilize the idea of SAS packages, about which I'm going to talk to you tomorrow in the same room about 3 p.m. So 44 minutes earlier than now. Thank you very much. Hope you enjoyed. If you have any questions, just shoot me. I'm here.
Thank you, Bart. And, question? Yeah, 2 words above your name. What does it?
Oh, those over there? Mm-hmm. That means thank you in Polish. Dziękuję bardzo. Sorry, forgot about it. Thank you very much.
Means thank you. All right. Thank you, Bart. And we're going to get the other laptop going. And so our final presentation of the day is by, I should have asked you how to pronounce your last name earlier. Delgoff. All right, I was correct. Brooke Delgoff. So her professional background includes significant contributions to healthcare research and data analysis at Marshfield Clinic Health System. In her role as senior research programmer and analyst, she was instrumental in preparing electronic health records, dental chart, and insurance claim data for research studies across diverse areas. And Brooke is currently the operations chair for the Midwest SAS Users Group, which occurs later this year. So, Brooke, take it away.
I might move. We'll see. All right. So, my name is Brooke Delgoff, and today I'm going to talk to you about REDCap, but as she mentioned, I am the operations chair this year for the Midwest SAS Users Group, and we're still very much in the planning phase, and so I want to do a little exercise here, mostly because it's getting late in the day, and so we are all thinking about opening session, which I'm sure we are getting razzed about. And so I'd like to just have this here. And raise of hands, how many of you know that there is a Midwest in the United States? Okay, that's good. How many of you have been to the Midwest of the United States? Okay, still pretty good. How many of you have been to the Midwest SaaS Users Group conference before? Okay, not as many hands. This is your opportunity. So if you have ideas about how to make that conference something you want to go to, this is the email. I want to hear about it. And I'm still building my team, so if you want to be involved in it, it's a great resume booster. It's a lot of fun. I definitely enjoy working with all of the people that I get to meet at these conferences. And one thing that you'll learn is everybody's very friendly. If you want to be part of our exclusive group, you just have to ask. So please do reach out there and find me at this conference. Talk to me about it. I really want to hear what you have to say. And if I cannot keep your attention, my standard poodle, Remy, is a therapy dog. This is her Instagram. And please scroll that. It brings happiness every day. And this is her at the Midwest SaaS Users Group Conference. This was a couple years ago, and she will be there again. And I hope that you don't travel there just for the poodle, but if you do, it's all right. I'm happy to see you, and I guess I'll get on to the business then. I work for a healthcare company, health system. It used to be Marshfield Clinic Research Institute. This year we were acquired by Sanford Health out of the Dakotas. And so, no, I did not leave Marshfield Clinic. Many of you who know me know I love my job, and I did not leave. We just became someone new. But what didn't change is my commitment to keeping our patient data safe, but also keeping my code freely available to use. So here is an outline. And the first thing that you might be asking, if you haven't seen my presentations before, is what is REDCap? So that's a good place to start. And we're going to do one more activity. We're going to pass around both a save the date, which will make a calendar reminder for Midwest SaaS Users Group. I'll go one on each side. And then all of my content is available via a REDCap survey, which is how I distribute my materials. So this is a QR code where you can find every paper, every piece of code I've ever written about REDCap, and many other things too. So if I don't finish my talk today and you were spending your time writing me an email about your ideas for Midwest, that's okay. You can still see my presentation. If you didn't get the QR code or it passes you too quickly, at the bottom corner of my presentations is also that QR code. All right, so what is REDCap? REDCap is described by Vanderbilt University, which is its creator, as a secure web application for building and managing online surveys and databases. And that's a very lovely description. But what it is to me is the way that I create clean data. And so I want to talk to you today about just the basics of why I like REDCap and one solution that I've created to work with it. But I love to present. I talk way too much. And so here is one more opportunity to see the different things that I've presented about REDCap on. Today, I'm going to pick my fan favorite, which is about the API Playground. Now, how many of you have used or are only using open source languages? Okay, a few hands. I know we're here for SaaS, but the API Playground actually does many different languages, and what it does for you is it writes code. It writes code for you. And so if you are new to REDCap, you've never used it before, and you think, how can I get my data out of there? How can I create a report? How can I dynamically update the different users that have access to my project? How can I do any of those things? You can come to the API Playground, and it'll write that code for you. And so that's quite a nice feature. This is built into REDCap. And on the front end of REDCap, you see a survey or a form, just like you've seen many times before. But on the background, that data is nice and clean, and it comes out very easily with very little effort. Before you can do that, you need to have permission. And the API token that you use in here works like the other tokens that you're familiar with. So be careful with it, because if somebody uses your token, it'll look just like you accessing that data, but it could be somebody else. So if I have one red flag warning on today, be careful with your tokens. And then I'll play a demonstration because I like the visual. It is supposed to have audio. Okay. I will read you the subtitles because I'm the one who was speaking it last time. Welcome to REDCap. From the left-hand side panel, you can select the API Playground underneath Applications. Here you'll find that the API Playground is capable of many things, and they're provided to you in a drop-down. During the presentation today, I'll go through a couple of these things, including the data dictionary download, export of records, and export of reports. The API Playground allows you to create code automatically using familiar and easy drop-down options. For right now, I'm going to select to export records. Once you select export records, there's a couple other options you'll need to select. First, the format, and then any restrictions you want to have on what's being exported. For example, selection of specific records, fields, forms, events, and so on. Sometimes technology does just fail you because now the subtitles are not showing either. So at this point, I'm just going to be forced to see what's on the screen and tell you that this is me running that request in real time. And down below it, you will see that there are tabs for many different languages there. PHP, Perl, Python, Ruby, and what you don't see in there is one that says SAS specifically. But what you do see is one that says CURL. And so if you didn't know it, SAS can actually speak many languages, even more now with the VIA platform. But what it could speak all the time was HTTP. And so this CURL actually does provide the exact string needed to run proc HTTP. not go to the next one. Okay. So once it tells you that string, it says, here's how to get your data out, here's how to build a report, here's how to select only records 1, 2, 3, 4, and 5, whatever it gives you, you can then take right out of there and place into proc HTTP. So before we export that, I want to go back a minute and teach you the data structure before we export the data. So if you export something from the front end of REDCap, this is what it'll look like. It has some automatic variables that are present every time for the record ID, a repeat instrument, and what instance, if it's been repeated before. And then it has some fields that are specific to the form that you've created. If you think about a survey, these would be the answers to your survey question. Each row represents either an instance or a record or a combination of each. All right. So looking at the reports, this is what it would look like on the front end. And this is my REDCap. I use it to see, who has been looking at my code. I want to make sure that my code is still being used. It's how I get my employers to say yes to doing more things like this, as my usability statistics. And so one thing that I keep track of as you look at my code is where you saw it. And if I go into REDCap, I can see how many people have seen it. I don't collect any identifiers on there, and it creates a report for me. Now, sometimes I would want to export the full report, but not always. After today, I probably want to look at only the people who said that they saw my presentation at Innovate. So understanding whether you want to export the full report or just the report-based report, the report-based export is really based on usability. And so in REDCap, if you're already subsetting to create a report that tells you, who saw my paper at Innovate, you don't also have to reprogram that in SAS on the output. In that case, you probably want to just use the report that you already created within REDCap. So to do that, again, you're going to pull that right out of the playground, but if you wanted to know what part of that string is pulling from the report, it's the ampersand report underscore ID. And if you're wondering how to identify what the identifier is for your report, those are listed in REDCap next to the My Reports and Exports area. In this case, you can see some identifiers there, and the screen is still not moving. There. Okay. Another thing you can do is change the export criteria. And so maybe you don't want to export all records, and I'm going to call that a limited variable export. Sometimes you're creating surveys that have thousands of questions on them because you wanted to create a field for each time that they took a blood pressure, and they did that over a series of 30 days. And so quickly you can have a lot of different variables. At the end of that, maybe you calculate a summary or an average of their blood pressure, and you think to yourself, I just want the average. I don't need all the individual data points. Again, when to think about that? Well, operationally, if you want to report on the individual items, then it makes sense to export based on the report. But if there's no one on the front end that needs your summary statistics and you don't want to clutter their view of the different reports, that's a great time to do a parameter modification. Again, if you pulled that out of the playground, it would give you this string, but the operator there is the ampersand fields equal. And in this case, I'm using a macro variable to fill in the fields that I'm interested in. In REDCap, it does give you a code book, which does give you all the names of the variables. And typically, the person who created the REDCap is also the person who's doing the SAS programming. But if you forget what you called something 10 years ago and it comes back to you, it's still very helpful. Then there's the behind the scenes data. I call it supplemental data. Some people call it metadata exports. These can be really helpful if you're trying to understand if something was changed in REDCap, because REDCap does keep a full history of what that value used to be, who changed it at what time. And so it can be quite helpful when you're trying to identify if data were changed or understand something like abstraction time. How long is it taking people to fill out this survey? How often do they go back to change their answers? Or questions like that. In that case, the operator there would be the ampersand content equals metadata. And this is kind of a subset of what that data would look like. You can also export logging. And remember how I said it keeps track of what the value was over time and who changed it and at what time. This is what it would look like on the front end. And then here's just some ways that you can use that. And the operator there would be ampersand content equals log. Now, I've talked about a lot of ways that you can put data or take data out of REDCap, but yes, you can also put the data into REDCap. So one way that you can put data into REDCap is by doing it manually. You can create your Excel file using SAS, and then you can upload it directly on the front end of this. Why would you do that? Well, the import tool does do this really nice data comparison table that does look to tell you what changed. And so if you're using this to update your data and you want it to perform that check against what's current in there, and you might have already programmed that in your SAS code, most people do, but if you're me and you just worry about something changing last minute because REDCap is real time, somebody could have changed something while I'm performing an update. Generally, I will still run this on the front end if I'm working on live data, just to be sure nothing that I don't want to change is changing. And then kind of just an overview of what method should be used. So again, for me, I really use the front end if I'm trying to be really careful about things that might have changed since I downloaded data. If I ended up taking a little bit longer to work on the data, then I'll typically use the front end. Otherwise, if it's running on a scheduled job and it's doing so on a Sunday at 3 a.m., then I feel pretty confident that we can probably just do an export and an import. All right. All right. Well, REDCap is something that I use all the time, and it's some of my presentations that have been best attended in the past have all been REDCap papers, and so I know it's a tool that's being used. So stay tuned. Any questions? Yes, all the parameters can be used in conjunction with one another. So if you went into the playground and you selected those options at the same time, you could definitely do that. All right.
Thank you, Brooke. And let's give everyone a round of applause when we're all of our presenters. Thank you. Thank you. So I just want to do a quick little recap and remind you that this event was all about our SAS user groups. So if you like the content you saw here, then there are, like I said, 16, 17 just in the US user groups that you can attend. And we've heard from Boston, Michigan, Western users, Poland, Midwest. But we also, here at the conference, have representatives from CSUG, which is the Southeast and Atlantic SAS user group. NotSUG, they were here earlier, that's the North Texas, right here in our backyard. There is a new one starting up in Pittsburgh this year. There's interest in starting up one in Kansas City. So if anyone's from the Kansas City area, let me know. We've got the Nordics and UK and Ireland here represented. And then we have Arizona with Valley of the Suns represented. And so that's just a small sampling of the user groups that we have. And PharmaSUG, yep, absolutely, pharmaceutical SaaS user or software user group. And then, you know, there's so many. We have a lot of, you know, One Day, New Jersey, Philadelphia. Like I said, we've got Boston, Michigan. So I encourage you to go out on the SAS website, just Google SAS user groups, and you'll find all across the world. So not just in the US, not just in the Nordics. We have Canadian user groups. We have Japan has a SAS user group. Asia Pacific down in Australia, they're restarting their user groups. So there's a lot of information that you can glean from going to these user group meetings. Some of them have virtual events. So I encourage you to, if you like what you saw, Lex Jansen, I believe, Bart, you had some papers that were listed on Lex Jansen's, lexjansen.com. You can go out and find presentations from any of these presenters and from hundreds, if not thousands of more presenters, going all the way back to one of our very first, you know, Suji events back in 1976. Yes. Thank you. I'm the employee, and I'm looking to these guys to help me remember when the events were. So so thank you. Lex is a real person. Yep. He used to work for SAS. Now he's gone to the CDISC. Yep. So he loves compiling papers and hosting them on his site. So that's where you can find them. Again, I'm going to be in the Innovation Hub. Franz is going to be there. You'll find all of our R&D, all of our product managers. We have more booths than I can count. So I encourage you to come to the Innovation Hub. There's a reception there this evening, and then we're open all day, Tuesday, Wednesday. So come talk to us, talk to R&D, let them know what you're doing, let them know the questions that you have, what you'd like to see from us. We're always interested in that. So we're running a little bit early, so we were going to have a reception from 5 to 5:30. I don't know how quickly they're going to set it up out there, but I encourage you, if you've got something that you can go do and then come back, it'll be a lot easier to get your food and drink out there than it will be in the Innovation Hub fighting everyone for food and drink. But for 30 minutes, we're going to have that, and our presenters are going to be around if you have questions for them, if you have questions for me. So thank you all for your time this afternoon, and it was lovely seeing everyone.